Sixth grade lesson 8.6 is solving multiplication and division equations. We've been modeling these. Now we're going to just go ahead and tell you how to solve them. And you've been hearing it. You just use inverse operations, opposite operation. I'll show you why both of those work for both multiplication problems and division problems, why that works to use the inverse operation to cancel out. There's first the division property of equality that says if you divide both sides of an equation by the same non-zero number, the two sides are going to remain equal. And here's the proof of that. Let's say I have 2 times 6 equals 12. We know 2 times 6 equals 12. Well, if I divide both sides by 2, this 2 divided by 2 equals 1. And 12 divided by 2 is 6. 1 times 6 is 6. It stayed balanced. If we use inverse operation and we do it to both sides of the equation, well, in this case, it wasn't inverse. We just did something to both sides of the equation, right? So it stays balanced. We'll also learn the multiplication property of equality, and that just says if you multiply both sides of an equation by the same number, they will remain equal. As long as you do the same thing to both sides of the equation to keep it balanced, it will remain equal. So if I have 12 divided by 4, we know 12 divided by 4 equals 3, right? So let's say I multiply both sides by 4. I would get 4 divided by 4, which equals 1. And 1 times 12 is 12. 3 times 4 is 12. 12 does, in fact, equal 12. So that is the properties that they show us to prove to you that you can use inverse operations to isolate the variable and solve for the variable as long as whatever you do to one side of the equation, you do to the other side of the equation, just like we did for addition and subtraction. So let's look at some examples. Okay, we have Mai, who ran 14 laps around a track for a total of 4,200 meters. They gave us the equation 14 times d equals 4,200 and can be used to find the distance d in meters that she ran in each lap. Solve the equation and explain what the solution means. Well, we're looking for the distance for each lap, right? What operation is indicated by 14d? Remember, anytime we have that coefficient next to the variable without an operation showing, we are learning that that means multiplication. So we're doing 14 times distance. All right. So let's go ahead and have a look at what happens. They tell us in order to get d isolated, our variable isolated by itself, you must undo the multiplication of 14. We will use inverse operation. Divide by 14 is the inverse operation to multiply by 14, that opposite operation. If it's being multiplied by 14, let's undo it by dividing by 14. If we do that to one side of the equation, we must do that to the other side of the equation as well to keep it balanced. 14 divided by 4 is 1. It cancels each other out, so you'll see me always crossing that out. And you know 1 times d is d, so that just leaves us with d, identity property of multiplication. 4,200 divided by 14 ends up being 300. So we find out that the distance is 300. Did it say what the measurement was? Meters. 300 meters for each lap. They say you can check the equation. Now that we know that d is 300, we can plug that in. We would substitute 300 for d. Calculate, calculate, calculate. 300 times 14 would give us 4,200. And yes, that does check out. So the solution means that May, or however you say her name, ran 300 meters for each lap. Okay, another example. And oh no, they gave you fractions and you're in a panic. No, no, no. You should be thanking these book people for giving you fractions so you can dust off the cobwebs and remember how to calculate with your fractions. Thank you, book people. We have solved the equation 2/3 times n equals 1/4. Remember, this is multiplied with the coefficient in front of the variable. Here's our equation. We're going to use which is going to be the division property of equality. I was going to say inverse there, but they want the division property of equality. That just means that I have n being multiplied by 2/3. The inverse of that, the opposite of that, is divide by 2/3. This property says as long as I do the same to this side as I do to this side, I'm okay. It will stay equal. So if I divide this side, the opposite of multiply by 2/3 is to divide by 2/3. If I divide this side by 2/3, then I must also divide that side by 2/3. They show you the calculation. You can just know that 2/3 divided by 2/3, just like 3 divided by 3 is 1. 2/3 divided by 2/3 is 1. They show it to you though, so if you were to cross reduce here, you'd get 1. Cross reduce here, you'd get 1. 1 over 1 is 1. That happens. Here, remember, 1/4 divided by 2/3, we do that keep, change, flip thing so that we can divide instead, and we can multiply instead of divide with our fractions. So we're going to keep 1/4 as 1/4, change to multiply, do the reciprocal of 2/3, flip it on its head so that we can just use multiplication skills. Cross reduce if we can. Nope, nope. Okay, no problem. Multiply straight across. 1 times 3 is 3, 4 times 2 is 8. And these had canceled each other out, with leaving me with just n. So n equals 3/8. Thank you, book people, for reminding me how to divide my fractions, keep, change, flip, and all that, right? You can still do it. Don't let those scare you off. Okay, example 2 gives us another example. It's the last one they give us, and then we're on to the share and show. I may choose a few of those share and shows to do as an example for any of you who want to see a few more, or for those of you who are like, I totally get this, I don't need you anymore, then you can go. You don't need to keep listening to me when you understand it. A biologist divides a water sample equally, among 8 test tubes, so splitting something into 8 pieces. Each test tube ends up containing 24.5 milliliters of water. Write and solve an equation to find the volume of the water sample. Okay, write and solve an equation. Information. They divide something up equally into 8 test tubes, and each test tube had 24.5 milliliters. So we're pouring an amount that I don't know into 8 test tubes, 8 of them, 8 test tubes, and each one of these test tubes is 24.5 milliliters. So I have an unknown amount. Let's call it, I guess we're calling it V because that's what they put there, so let's use the same. Let V equal the volume of water that we, or I guess it's a sample. Oh, it's a water sample, yeah. So the volume of water. And we're going to take that original amount and divide it, poured it into the test tubes into 8 equal amounts. And when we're done with that, each of those 1 test tubes will have 24.5 milliliters. So there's our equation. To find out how much they started with, which is the question they want us to answer, we're going to solve the equation. This is V being divided by 8. What is the inverse or opposite operation of divide by 8? Yeah, it's multiply by 8. So this is called the multiplication property of equality. As long as we do the same to one side as we do to the other, we'll be fine. So I'm going to undo divide by 8 by multiplying by 8, and I promise to do the same to both sides of the equation to keep it balanced, just like we've been doing in all the previous lessons for addition and subtraction and things like that. This 8 divided by 8 cancels out to be 1, leaving me with just 1V or just V. And then I just need to calculate 24.5 times 8. 24.5 times 8, 32 plus the 4 is 36. 8 times 2 is 16, 17, 18, 19. Baby in the car, 196. So they started with 196 milliliters, and then they slowly poured them into 8 separate tubes, leaving them with 24.5 in each test tube. Okay, I chose to do this one with you. It's a decimal, so let's have a look at this one. 2.5 times m equals 10. M is being multiplied by 2.5. The inverse or opposite of multiply by 2.5 will be to divide by 2.5. We must do the same to both sides of the equation to keep it balanced. 2.5 divided by 2.5 equals 1, leaving me with just 1m. 10 divided by 2.5. Well, there's a decimal in my divisor, so I'm going to move it once to get to the end, and I must match that. All this fairness going on. Math is so nice and fair. If I moved that once, multiplied by 10 once there, must do the same over here in the dividend. 25 goes into 100 4 times. M equals 4. That's how you solve that. How about another one? Let's go with 1/3 n equals 15. Here is my variable. My goal is always to isolate my variable. He's being multiplied by 1/3. So I'm going to divide by 1/3. Divide by 1/3 to both sides of the equation. 1/3 divided by 1/3 cancels out, right? Because you get 1/3 divide by 1/3, keep, change, flip, cancels, cancels. Well, it reduces down to 1, and you get 1/1. There it is for your brain to see to prove it. You don't usually have to do those steps. You just, if I have multiplied by 1/3 and I divide by 1/3, it's going to cancel out to 1. Here I have 15. Let's make that 15/1 divided by 1/3. Keep, change, flip. 15 times 3 is 45, right? 45 n equals 45. All right. Hopefully it's starting to get the hang of it. I'm going to show you this one too. Let me see if I can make, nope, it won't let me erase that. I'll go to a new screen. Okay, I have 25 equals a divided by 5. I chose this one on purpose because my variable's on this side, and sometimes that throws some of my students off. Again, your goal is to isolate the variable. So sometimes people are used to seeing the variable on this side and like, wait, what? And they start subtracting 25. Nope, look for the variable. Here's a variable on this side of the equation. Okay, my goal is to get him to be a loner. So he's being divided by 5. Opposite of divide by 5 is to multiply by 5, but I must do that to both sides of the equation to keep it fair. That cancels out, leaves me with just a. And 25 times 5 will give me 125. So there's a few examples. If it's doing division, then you multiply both sides of the equation. If it's doing multiplication, then you divide to both sides of the equation, and that's how you solve for the variable. That's how you isolate the variable. Hopefully that was enough to get you to see how to do that. Happy to help if you need more.